Now we are going to the practical thing, how to graph. Okay, if you are shown these kind of problems, it is that you try to solve 3x minus y equals -1. It means that you have to find all possible solutions, the combinations between x and y to satisfy this equation, right? And then you show all the solutions by graphing, since graphing is the most effective way to show all the solutions. So the objective is, let's find all possible pairs of x and y to satisfy the equation. The first approach that you can do to make it easier for you to find all the pairs is by converting the equation. So I need to convert this equation into a statement of y equals something. You need to isolate y. So let's just convert that by, yeah, you can using the additive property of equality, and then multiplications property of equality, and then in the end I will find this is my equation. Okay, this is exactly the same with the previous one, but I'm just changing the form, so it will make me easier to find y when I just use some specific value for x. Okay, so now after I find this equation, let's start to find the pairs. So I will use the table here, okay, just like the previous example, x, y, and the pairs. So first let's try to use any values of x, okay, from a specific domain. Since it is not stated what is the domain, it means we can assume that we use real numbers as your domain. So you can use any real numbers to begin with, to start with your x. Well, I use with the easiest one, I will use 0 as my starter. Okay, I will use 0. If I use 0 as my x, what is the y? What is the pair? So to find what is the pair, I use this equation. Okay, and then I will just substitute my x into this. So in the end, I will know that my pair, the y, is 1. So this is my first solution, the first ordered pair, 0, 1. Okay, next I will try another values of x from real numbers. Well, it's easier for us to graph with integers, right? So actually we can include any decimals. We can try 0 0.5 for your x, 5 point something for your x, or even radicals. Okay, so again, as long as it is included in your domain, you can use any values of your x. But let's just try 1. If my x is 1, then I will use the same equation here. I will find the y, the pair is 4. So the second solution, 1, 4, and you can be certain that 1, 4 will satisfy this equation if the x is 1 and the y is 4. And you can continue to use other values of x. Now I begin with -2. So the y by calculation will be -5. So this is my third pair, and you can go continue, and in the end you know that it will be endless. Okay, it will be endless, and maybe we can start to graph from this. Now let's graph that equations. Since we are involving two variables, it means we need the Cartesian. Okay, again for the Cartesians you need to complete the label here for the horizontal. Okay, let's put the x here and the y on the vertical, since y depends on the x. Later I will just explain you about dependent and independent. And then you have to complete with the tick marks, since we need to know what scale that you use. So for this one grid is 1 unit, 1, 2, 3, 4, 5, 6, and so on for the x. And to the left, it is -1, -2, -3, -4. Okay, and for the y, I will use the same scale, 1, 2, 3, 4, 5. Okay, so be aware that you need to be consistent to use the same scale for one number line. So for example, actually this is the number line belongs to x, and then this the number line belongs to y. And so for the number line belongs to x, you need to be consistent from to the right to the left, what is the scale you use. And for the number line of y, you need to be consistent to the top and to bottom, what is the scale. Okay, that is the rules of the Cartesian. Now let's plot this. Okay, I will try to present you what is the pairs that we have found so far. Okay, so yeah, we have found 5 pairs. So let's just plot these pairs first. The first pair that I want to plot is this 1 comma 4. So I will find 1 as my x here. Okay, the vertical I project it vertically, and then 4 from my y. Okay, the intersection will be here. So this is my 1 comma 4, and then I will try to plot the second solution, which is negative 2 comma negative 5. So yeah, here it is, negative 2 for my x, negative 5 from the y. So the intersection is here. Okay, so let me just discuss about how can you be satisfied with the ordered pairs that you have found to assume what is the graph is. So since if I'm only using these two ordered pairs, this still is not enough for me to conclude what the graph is. Okay, let's just playing dumb, and we don't know what kind of shape that this graph is. Okay, although we know it's linear, but if you have only two ordered pairs, you cannot just assume it is a straight line. Okay, since I will just give you example, actually it can be like this. Well, this graph is actually also includes these two ordered pairs as its solution. Okay, so we can have any other variations, maybe curving like a snake, and if it covers these two dots, two ordered pairs. So again, you cannot do this. Okay, instead what we are doing is we plot more of it. So let's just plot the third one. For example, let's just plot this. This is 4 comma this is well, this is actually is not included at the beginning. It is 3 comma 10. Okay, a 3 comma, yeah, 3 comma 10. Okay, let's just use 3 comma 10. For example, if I use 3 comma 10, and then can I conclude that this must be a straight line? It's actually it still cannot. It's not safe, right? If the graphic is like this, for example, so actually this graphic is also consists of these three solutions, 1, 2, 3. Okay, therefore that's why it is safe for us to find as many as possible that we can, and then we can start to assume after it shows a consistent pattern. For example, if I'm just plotting more of it, right, I plot more of it. Look at this, all of the solutions that I have already searched, when I plot it, it consistently showing the pattern is a straight line. Okay, and in the end, maybe now I can assume that it is a straight line like this. There. Okay, if you are still uncertain, you have to know that this straight line, this graph, shows that all of the pairs on this line will satisfy this equation. Again, if you want to confirm whether your graph is right or wrong, you need to check as as much as possible, as many as possible, all the dots on the line, anywhere on the line. For example, this one, this is the pairs of what, x and y. It needs to satisfy your equation. Okay, and so let me just make a quick review that the solutions of this is represented by this graph. Why? Because all of the dots, all of the pairs on this line are the solutions for these equations. If you pick any pairs on this line, any pairs, for example this one or this one or this one, the x and y of that pair will satisfy this equation, or will make this equation statement is true. So the second one that I want to discuss is this graph. Okay, y equals 1 over 2 times x squared. Now let's just find, okay, the objective, let's just find all possible pairs of x and y to satisfy the equation. and then let's show all of the possible solutions on your graph. So let's just, because this is already been isolated, okay, the y equals something. So yeah, let's just find the pairs, since we have already had the equations in the y being isolated. So let's do the pairs here, table. So let's begin, since there is no specified domain here being stated, so we can assume again we use real numbers. So you can start with any real numbers to replace your x. Now let's start with 0. So if I put 0 there, my y will be 0 also. So this, the first pair, the first solution that can satisfy this equation is 0 comma 0. If I continue to x equals 1, I will find that the y equals 0 0.5. So this is my second pair, 1 comma 0.5, and so on. Okay, so after we find as many as possible, you can find, of course, the objective is you need to know first the pattern. Will it consistently show a specific pattern? Then you can conclude what is the pattern is. Is it curving? Is it a straight line or anything? Okay, let's go to the graph. So this one, by graphing y equals 1 over 2x squared, I will use different Cartesian. What I mean different Cartesian is I will use a different scale between the x and the y. So the x, the scale is by 2 grids, it is 1 unit. Okay, 1, 2, 3, 4. But for the x, since this is belongs to the x-axis, you need to be consistent both to the left and to the right. So you cannot present different scales on the negative sides and different scales on the positive sides. No, it is not suggested. And for the y-axis, I will still use 1 grid is 1 unit. Okay, so whenever you're consistent in one axis, there is no problem if you use different scale for different axes. Okay, so now let's just state it, what is the all of the or the pairs that we have found so far. So what is the shape of this graph? How can we graph this one? So let's begin with the first pair. It's 0 comma 0. So 0 comma 0 is here. Okay, it's easy. And then the next one is 1 comma 0 0.5. So it is 1 for the x and 0 0.5 to the y. So it's there. And then 2 comma 2, it is there. 4 comma 8, it is there. And then after I try to complete everything, okay, so I can see that actually it's hard for me to make a straight line, since since my graph needs to connect all of these dots, right? So if I'm using straight line, it's not the pattern that is supposed to be. So in the end, you will find out that actually it will satisfy the curve. So if you are still uncertain about this, again, you need to be sure that all the dots on this curve, if you pick a dot as an ordered pair on this curve, has to satisfy this. Okay, so for example, if you have this kind of graph in mind, yeah, it can be like that, it can be. But again, the question is, will all the ordered pairs on this line will satisfy your equation? That's the question. So if I pick, for example, this one, this is negative 3 comma 2. Negative 3 comma 2 is one of the solutions. It is on the graph. Will negative 3 comma 2, negative 3 my x, and the 2 is 2 for my y will be valid. So yeah, that's how you check it. The last thing that I want to explain is about domain and range. Although I will explain later completely on the next video, but let me just introduce you about the domain and the range. Domain means all of the x. Okay, so when you substitute all of the x into this equation, it must comes from the specified domain. So when you try to use the x values, if it is, for example, I regulate the domain must be only odd numbers, it means you cannot use 0, you cannot use 4 or negative 2 as your x. You can only use 1, 3, and so on. Okay, so the domain regulates all of the x that you can use to substitute the equation, and the range are all the y's values that comes out because you used the domain. Okay, so all possible values of your y based on the x that you use from the certain domain. So let me just put it this way. If we use the same example from the previous one, 3x minus y equals -1, we know that if the domain is all real numbers, it means the graph itself is this line with arrowheads at both sides. Why? Because it will be continuously go there and continuously go there. So I can be certain that my graph will covers with to all values of x. So if my x is -5, -15, for example, Mister, there is no graph on the -15. Actually, there is, since it is continuously go there. So in the end, if you try to project it, you still can find what is the value of your y. So this graph covers all real numbers as your domain. And the range is the y. What is the values of y that comes out from the graph? It is all real numbers also. Okay, since you can find on this graph any real numbers for 10, -10 for your y, it exists. They exist. So now let me change the domain. How if the domain I regulates it's only between -2 and 3, but real numbers? It means the x that can I use to substitute these equations is only the x between -2 until 3. So 4 it cannot be included, and the solution itself will be limited since I'm only involve the value of x between -2 and 3. So in the end, your graph will be different since first there is no line ends, right? Since there is a limit to your graph, and since it's the last x is 3, so I will just make this, I will just, yeah, and the left border is -2. Okay, remember domain speaks about the x. So actually I cannot include this, I cannot include this. This is not the solution from the specified domain. So it's only this, the graph becomes like this. Since I only includes from x equals -2, okay, -1, 0, 1, 2, and 3, up until 3 ends, right? So the domain will limit your graph since all of the solutions that being represented by your graph, all of this, okay, must satisfy this, of course, but the x that being represented, by that being viewed, being displayed, must comes from the specified domain. Okay, so if I use, for example, the previous one, why this is wrong? Because this graph shows there is a pair that is 4, 13, and the x is 4. This ordered pair, but it's really violate the domain since 4 cannot be involved for your x since it is not from the domain. I hope it is clear. Okay, so this again, this is the right one. Okay, and what is the range? The range is all possible values of y that comes out because you have limit the domain. Since now we have a different graph, there's a limit there and there. So can you figure out what is the values of y that comes out from your graph? The value of y that comes out from your graph is only the y between -5 until 10. Okay, outside of that there is no value of y, because we cannot find any graph that includes a value of y outside -5 and 10. That's why this is the statement. Okay, so we have the same equation, but when I use the different domain, the graph will be different, since it's like it being cut. And then you can see that the range will be different. It is not all real, but it will be between -5 until 10. Okay. And how about this domain? So if I regulate that the domain must be only between 0 until 4 and must be integers, it means all of the x that I use to graph or to be shown on the graph must be only inside the domain. So because it is integers, it means only 0, 1, 2, 3, 4. So this is not the solution. This is not the solution. This graph is not the solutions of this equation with the specified domain. Since this graph, this line shows that all x is all real numbers are included. So let's just eliminate this and let's just see the dots there. Since I only can include the x between 0 and 4, it means for negative x, it's not, cannot be shown on your graph, right? And 1, 2. Okay, so yeah, this is your graph becomes. It is not a line, it just dots, dots, dots. Why? Because I can only involve x equals 1, x equals 0, x equals 1, x equals 2, x equals 3, and x equals 4. Okay, if I put a line and connect that, it means I'm showing that all values between 1 and 2, 2 and 3, the decimals, are included also. Okay, so this is your graph if it regulates the domain integers. So now, how about the range? So the range is all values of y that comes out based on the equation and the domain that you use. Since we only have 1, 2, 3, 4, 5 pairs, 5 ordered pairs, it means we only have 5 values of y also. Therefore, the range, you can only state it specifically what is the value of your y. 1, 4, 7, 10, and 13. That is your range. There is no other values of y being displayed on your graph except this 5. Okay, again, different domain, although we have the same equation, can show you a different graph and can show you a different range. Okay.